In the last class, we just started the part of the beginning of the indexing structure. So we will continue because we have a lot of things to discuss today, and definitely it will be the important part of your final exam to make you guys pay attention to the lecture. I just gave the hint, not the rendering. Okay. So, what is the indexing structure? So, last class we have talked about the data structure for what? File, general file using database system. Anyway, after you design, after you create the internal level, there are the structure, the data. So, who is managing such an internal level schema architecture? The DBMS. Okay, your software knows how to store the physical your employee table, employee data, or department table. You don't have to worry about. Nobody knows when you are using the SQL Server. Do you know how your data is stored? No, but your DBMS. So we are talking about such an internal level data structure. So last class we have talked about the file structure where your data are stored. Okay, so we have the ordered file, unordered file, and the hash file, and something like that. However, when we are using the ordered file, even though the records are ordered by the key or the non-key, okay, so the fastest way to access the ordered data is what? Binary search. It still require log and the log number of block, okay? Based on the base 2. Okay, still it requires such the complexity. So is there any other way to increase the performance to access the data? That is the indexing structure. What is the indexing? I mentioned many times. If you do not understand what is the index, just take a look at your index on your textbook, any textbook. It has the keyword plus page number. Keyword is the index, the field value or the key item, okay? The index data, okay? Value of the index data. And the page number is the same as a pointer to record. Pointer, the page number that point to the page where you can find the keyword information. So it's exactly the same. So field value, the index, the key value plus the pointer address is called the index key entry. So this is the basic item stored at where? Index structure, index file. What is the basic item in the data file? What is it? It's a record by record. Okay? The tuple by tuple will be stored at the data file. What about the index? Index will have the index key item instead of the record. Okay? The different thing is in the data file. So data file is a record by record, but index file is the index key entry. Okay? So this is the record. But what about the basic unit of the physical storage? It's a block. Index also use the block. It's a file, but it's based on the number of blocks. But different the organization, different data. So this one use what? The ordered file, one unordered file, one hash file, and so on. This one we will discuss today. How we are going to organize the block, index block, to speed up when you access the data. That is the goal of topic of the today's lecture. Okay. What will be the best way to organize such an index block? Numbers? Number one. So for example, when we have the such a, this one is what? This is the record, which means data file. It's our table. So what kind of table is this? It's based on the block. So each one represents a block. And when you see the name is a primary key value, they are already ordered, sorted, right? So this is a ordered data file for employee table consisting of the number of blocks. But at that time, so without this one, how can you access the data? You can linearly access data, or you can use binary search. Okay? So we have seen the last class how to access and how much faster is that. What if we have the huge number of blocks? This table is supposed to have 10 petabytes size data, which means what is the logarithm graph? Did you take the pre-calculus before? So what is the logarithm class at the graph? This one. Oh yeah, that. Okay. It's a monotonic increase. That means even though this is better than what? This is a linear. It's better than linear, but still, when you have a huge number of the data block, still this will be increased. Okay? So it will take a time. Some time when you have a huge number of blocks. So how can we speed up that? At that time, we are going to use another data structure, that is the indexing data structure. Okay, so that is our topic. So first, we are going to back and see what kind of the index. First one is just like your textbook, the index. Okay, this is the index of what? Keyword and pages. So we can have such a. It's a one level of the. Is there any depth or complicated? It's just a set of index key, the key item, right? Keyword plus pages. So it's called a single level index. Okay. So first, there are two types of the index as we discussed briefly before. One is the non-dense sparse index. Sparse index means the textbook. Can you find all the word in your textbook in index? No. Some keyword, right? It's not all word, all the pages, but some keyword only. That is the sparse index. If you make the index for all the data in your textbook, that is called the dense index. So, do you recognize the difference? The difference is whether or not you make the index all the data or some of the data. So that is a dense index, and there is the sparse or non-dense index. Okay. So for example, so this is the index. Okay. This is called the primary index. Primary index is it is based on the primary key value. Even though this is sorted, it will take a time. So why don't we take out we have defined the first data as the anchor record. What is the anchor record? It's a representative of the each block. So in this case, A1 is the representative of this block, and next one, the John Adams is the representative of this. Okay, then take out such an anchor record. Anchor record, this one, this one, this one, this one, this one, then bring into this block. Okay? Then sort them. Okay? Then this is called the primary index on the employee table. How can we use such a primary index when you search the data? So, the index of, before that, each data has what? Key value and pointer. Key value and pointer. Always index has the key item that include the value plus the pointer address. Okay? So, we have the error from the first block, Adams from the second block, and so on. Then this one is the one block. Okay? So one block is, for example, 512 byte. So 512 byte is limited. There might be a number of the index key entry. Okay? It's limited. That is called, in data file, what was the name of the average number of records in one block? Blocking factor. So that is a BF file. In index, it's the same idea, but different name. It's not record, so it's called a fan out. Fan out means average number of index key entry. Okay? So in your project B, case 1, you need to decide what is a fan out per each index. Right? FO. That is what you guys need to do. It's the same as blocking factor, but different name. So this is a block, index block. Index block has number of items. They are sorted already. Then when we search the data, we can apply binary search for index. Okay? Then using the item and the address, you can directly access the block, data block, then that's it. Let's see how it works. So for example, I'd like to search Anders block. Okay? This data, Anders. Is there any way to remove? Is there anyone who ever used? After write this, I will figure out next time. But anyway, right now I do not know. So Anders, so he's here, so I try to search it. First, we'd like to search where Anders is located. Actually, Anderson is not the anchor record. Okay? That means it's not here, but we can find the index key entry that include the Anders block, right? Because it's a sorted. So how can we find? Cut in a half. So for example here, I cut in a half the Anders A and block is the here. So we throw away the second half, to go to the first half, cut in a half. So Anders is the second group, second half, and finally we can find Anders block is the between Alan and Anderson. Okay, which means it belongs to Alan through the block. So then we know that this address of the block going to this one, and that's it. How can you search Anderson block in this block? How can you search? You can do the binary search, you can do the linear search. It doesn't matter why, because it will be done in the memory. So it will not take a time. So we can just consider to search the data in one block, it's just one. Okay? So that is what how index can help to speed up the data. So let's take a look at. So that is the primary index. So for the index for the ordered file, and also how many level? So just one level more. So called the single level index. It's another file, another data structure only for indexed block. So there is a way to verify how much you can speed up for using index. So for example, so we have the employee table like this one. So this is the employee table. Employee table consists of the name, social security number, and so on. So attribute. And these are the given information like the average record size 150 byte and block size is 512 byte. Then and also we have the 30,000 record. What is a blocking factor? Blocking factor is you can divide the number of records divided by the block and the floor as a ceiling. Okay? At least you need 1, even though we have the 1 record. Then what is the blocking factor? It's in this case 3. Actually you can roughly guess. So 150 and 512 byte, it may have the 3. Okay? So you cannot have the 4. So number of block you can divide by the blocking factor for the number of records. So you need a total 10,000 blocks. Okay, then for example we have the index for the like this one. Here is a different tool. Why don't we make the index for social security number? Okay, social security number. To make the index key entry, social security number plus address pointer. So what is the social security number size of the social security number? 9 byte. So we need a 9 byte plus address. Here, is there any information? Pointer size is 7 byte given. So total, how many bytes do you need for each index key entry? 16 bytes. Okay. So in other words, to make the index of this one row, this is a 16 byte, 16 byte, 16 byte, something like that. Then, what is the average number of index key entry in this case? You can divide 512 byte divided by 16. Okay, that is the 31 point something. So that will be the, I think that in this case is divide by, right? The exact. There is no remainder, so that is a 32 entry. This is not the blocking factor. Actually, same idea, but it's called the what? It's a fan out. So this is the fan out in index and the indexing structure. Same idea as the blocking factor in data file. Then, how many blocks do we need for the index? So you can divide. In this case, how many? So we are going to build, in this case, the R3000, which means a density index. Okay? In this case, a density index. We are going to create the density index. So 30,000 record index key entry divided by 32. Total, we need 938 index block. Okay, we need. Then, how can we search? First, we can search from the index using binary search. Binary search, if you are using the binary search, that is the logarithm here. So 10 point something. How do you know? So 2 to the power of a little bit less than 2 to the power of 10. You learn the logarithm, right? So log 2 to the power of 10 is what? It's a 10, right? So less than 10, which means the 9 point something, but it should be 3, right? At least you need to entire block. So you need to 10 block to find the what? Index, correct pointer address. Okay, then is it done? We need +1 data block. Okay, because it's pointed, it's the address, so we need to access. Otherwise, if we use linear search without index, linear search is a half, so 15,000 block. What about the binary search without index? That is logarithm of 30,000, right? If you calculate this one, this is the 14 something, so it's a 15 block. Which one is the faster one? Using index. Okay? So that is the reason we can get the benefit of the speed of using index. Any question? You need to understand this concept. This is just the basic concept of the indexing. If you cannot understand this one, it's a little bit tough to understand the next of them. So idea in this case, this slide shows how much we can speed up when we are using index to search the data in case the employee table. Okay? So there are different, so this one is a primary index. If we can make the index for the primary key, it's already sorted. Okay? Order the data. Then this is a non-dense index. Because we don't have to keep all the data, instead the only anchor data for each block, then make it. Okay, we can prove how much fast comparing to the linear search. Let's take a look at one more time the such evaluation. So, for example, it's the same example. We have the 30,000 record. The record length is 100 bytes. It's slightly different. The key value is the 9 byte and the block pointer is a 6, which means total the index key size of index key entry is what? 9 plus 6 is a 15 byte. Okay? If you know the 15 bytes, you can divide. The fan out is ceiling 5. What is the block size? 1024 divided by 15 and ceiling. Then that's what I couldn't figure out. Sometimes if I touch it, then it will move to the next. So in this case, where is so this is the, how much is it? It's calculate. Why? Oh, it's in this case it's not ceiling, it's the floor. Okay? Why? Because you cannot keep the part of the data, right? So you need to throw away the part of the data. That means it's the flooring. So if we apply the flooring, so that will be 68 point something of this one. Okay? Then we can calculate the buffering factor for the table, and this is the how many blocks we need. So in case of binary search, in this time no index, without using index, just a binary search, that will be logarithm of the 3000 blocks, that will be 11 point something, so 12 block access. We need a 12 IO to search the data without using index. But if we use the index, so we can do the same evaluation that we have done. We have the fan IO, this is a fan out, okay? And the record is here. How many block for the index? It's a 48 block. Why? Because for 3000 divided by the 68, so that is the, right? Okay, 6000 for the divided by 68, so we have the 45 block. So for this 45 block, so this is the 45 block for index. Then we have the table, how many block? 3000. So first we need to search the index using binary search, that is the logarithm of the 45 base 2, that is the 5 point something, so we need 4 point something, 5 point something. It's a 2 to the power of 4, 5, 8 by 8, 8 times 8, 64. So less than, so 5 point something. Okay, so 6 block access for index. So you can access the 6 times for the index. Then plus 1 is you need to access the data block. So total average is 7 block you need. You can compare how many block without index? 12 block. How many block do you need using index? 7 block. This one is so fast. So then query optimizer will select this one. When the same query, which means that using, in this case, the social security, whatever the keys, if the query use the key value, then check this one, this one is the fast. Then query optimizer suggests this. Okay. There's another type of the single level index, which is for grouping column. For example, department number. Department number is, in department is unique, right? But department number in employee table is not unique, but you can use the department number in employee as a group, right? Department number 1, we have this employee, 5. Department number 2, 6. Department number 3, 10, something like that. Okay, so such a grouping record, grouping attribute can be used for index also. This is an example. So why don't we sort the data employee table by the department? So how many employees for the department number 1? 1, 1, 1, 3. Then 2, 2, 2, 2, 2, 2, 2, 1, 2, 3, 4, 5, 5, 3, and so on. Okay. Then how can we make the index for such a department number? We can get this one. This time, which one is the representative? This one and this one? No. If we select this one, we cannot search the two. So in this case, we are going to use this one, this one, this one, this, and this as the anchor for each the data in the clustered grouping attribute. So you can make the index of the such a group value 1. Let's point the first block. 2, starting of the 2 anchor is in here. So point this block. 3 is in this second block, and so on. Okay. Is it the dense index or sparse index? So definitely sparse index. Okay, we keep the index item only for the different value in the clustering field. Okay, grouping attribute department number. We have to 1, 2, 3, 4, 5, 6, 7 different values in this case. Okay, this is called the clustering index. When can you use the clustering index? In case table is sorted by grouping factor. Okay, such a grouping or the clustering attribute, such as a department number. However, if your data is not sorted, like for example, I have this table. Can I create the clustering index? We can create, but it will be much more complicated. We will see such an example later. But because department number 1 is here, here, here. It's not ordered, right? So you need to point many of them. So we will see such an example later. However, this clustering index is in case the data files are sorted by the clustering factor. So for example, this one. There are 2 types. I don't like this one, for example, because one block has 2 different values. So you can actually separate the different value to the different column, a different block, like this one. In this case, it's a clustering index, but each block has only 1 value. Even though you have the space over here, so we don't care. However, what if the one block cannot keep all the data, in this case of 3, then you can have another block. But you need to link. So there is a pointer, block pointer, to point the next one. Okay? And so on, then we can have the clustering index like this one. How can we search the data? Using this clustering index. Apply binary search for index and find the block, then going to the first block of the corresponding the value, then search. Return all of them. These 2, in this case the 3, return all the data. That is the way of using clustering index. Okay. Still, it's a 1-level index, single level index. There's another single level index that is a secondary index. Secondary index means, why don't you take a look at this data file? This data file is probably sorted by, for example, name. So there's Aaron and so on. It's sorted by the name primarily. But I'd like to make the index for example, this is the social security number. I'd like to make the index for this column, which is not sorted. Okay? In case of the index column is sorted, we don't have to make the dense index. It's a non-dense index. We need to keep the only anchor value. However, in this case, if I want to make the index for non-sorted column, no way to find the anchor or representative, right? So in this case, we need to make the dense index, like the index column social security number plus pointer. 1 is, where is 1? Here. So point is 2. Where is the 2? It's here. So point this block. 3. Where's the 3? First, 2.
The second one.
Second. Oh yeah, here. So you can point this block. 17. For example. First.
Second one.
Second. Yes, second. 17. This, like that. This is the density index. For what? Non-sorted data. Okay. Then, in this case, what is the fan-out or blocking factor of index block? Oh, by the way, how many block? How many index block here? 1, 2, 3 index block. And what is the fan-out or blocking factor of the index block? It's 8. Okay. How many index key entry? 1, 2, 3, 4, 5, 6, 7, 8 index key entry for each block. Then, how can we search the data? For example, our query is select asterisk from is employee table where SSN is equal to 8, for example. This time, query optimizer will consider all possible S0, S1, S2, S3. Okay? S0 is possible. You can do the linear search, but this time it's not n over 2. Why? Because it's not sorted. You need to access anywhere all the block. So n block, right? That is the linear search. But we have the index for social security number. It's a secondary index. How can we use the secondary index? Binary search for this. Cut in a half. Half is the, let's say, this block. Now cut the real block, right? So this one, so here, 1, 2 is less, 8. So 1 block, you don't have to worry about the search in 1 block, okay? So usually in the memory, so then 8 is where? 8 is here. So finally, you can find the entire record return this. Okay? This is the secondary index. The primary index is an index for what? Sorted column. Secondary index is an unsorted column. You cannot keep the 2 tables. Okay? So you have an employee table sorted by social security number. You have the employee table sorted by the name. No, you cannot create such a table. Only 1 table. Then at that time, if we need another index, that is the density index. Okay. Any question? This is a secondary index. It's a density index. It's a non-key, non-sorted data. So you can verify how fast is that. I'm going to leave for your self-study. Okay? Why don't you? It's not very complicated, but I realize that most of the students has the very strong background, but they are sometimes they afraid to understand such a mathematical notation. There's no very complicated or the hard notation here. It's just a floor, it's a flooring or the ceiling and the logarithm. That's it. So why don't you try to understand and see difference between the linear search and the binary search for index and total number of access. In this case, 10 is much faster than 15,000, right? Is it true index is always fast? Yes or no? It's no. Many of the developer, database programmer, database developer, designer, they believe that indexing is the faster. So whenever their query is slow, they ask, why don't you create an index for this? Why don't you create? Why don't you create? Okay? Then even database administrator, they do not realize what happened, what's going on later after we create the 100 indexes in one table. That happened. But also, sometimes using index is slower than without index. One simple example is, so for example, I'd like to search the front page. Okay? This is the front page. Database system, fundamental of the database system. If you are using the linear search, you are lucky, so you can get the, you need just one IO, page open, one page open. If you use the index, first going to the index structure, and from the index structure using binary search, you need to search it, you need the 10, 11 IO, then going back to first page. This is slower. Also, I have a very small table, like the only 3, 4 pages. So even linear search, how many are you? 4 are you? 2 or 4 are you? Okay? Worst case, 4 are you, right? But what about the using index? You need to find the index, it takes a time. So depends on, okay? Not always the index is the fastest. Also, once you have create the 100 index for one table, so we have one textbook, but index is not only one. We have the 100 different index. What's the problem? I update the one page. It's typo. You need to update all the index. It takes a time, really takes a time. Also, what about the query optimizer? Query optimizer need to consider, find which the index is the fastest one. Only one index or the full table scan will be selected. Even query optimizer is getting slow when you have the huge number of the index. So usually 1 or 2 is the fastest number of the index. Why? Why? What is the relational database and what is a relation? Relational table should have what? Primary key. No redundant information, which means using primary key, that's it. You can find all the data. If you design perfectly your database design, you don't need any other way. Only using the primary key, if we design well and perfect, then the entrance door is enough. You don't have to use the word window, you don't have to break the new one. But sometimes for emergency plan, we need to use the emergency exit. So that is the reason in case we need to create the index. Otherwise, mostly the primary key is the best way, fastest way. However, in real life system, we need some other alternative route way. At that time, you can create minimally. Think about when you design your house, you make the 10 entrance door in your room. Do you think it's good for the design? Definitely not. It's the same. Okay. So please keep your mind. So once you graduate, when you join any database project, think about how you can use. At that time, if you do not have any concept of the relation or relational model, you don't understand why. I just ask creating index, that will be faster than without. So that is the problem. Okay, so in case of non-key means it's not sorted. There are several ways. Okay, so we can create the dense index. Okay, sometimes for the clustering, I will give the example about the repeating pointer because, for example, database key entry may have the several pages, several pointer. Oh, sorry. Several pointer, okay, because you don't know whether that is a unique or not. So sometimes you can have just repeated pointer, so you can make the group of the pointer, okay? And like this one, this is creating the another block, so that point the number of blocks. This one is the different. This one is the for index key entry, it has 1, 2, 3, 4 number of items. Okay, so that is for the secondary index for non-key, non-sorted. Okay. What if your table is so huge, right? That it needs millions of index key entry. How can you access the index data? Binary search, right? Binary search, as we have seen, when you have more block, it will take a longer time. It will be the same problem in index. If you have a very large index, also it will take time. What will be the solution? If your index is too big. No idea?
Index of index.
You can make the index of index. What if your final index is too big to find the data? You can make another index. Another index, that is multi-level index. Simple idea. Then probably those who proposed this idea 30, 40 years ago, so well recognized at the time. It was not easy to imagine such a simple idea first time, right? But right now, it's a simple idea, but it works. So that is this one. For example, we can create this time is a primary key, but it's a sorted or non-sorted. It's unsorted data. Okay, it's a dense index or non-dense index.
No, that's
It's a dense index because it's a 2, 5. Oh, it's a sorted data. Sorry. It's a sorted, it's an ordered 5, right? So it's a dense index or a non-dense index. It's a non-dense index, it's a primary index. But still, 2, 3, 4. 4 block is too huge. Actually not. But suppose that this is the too many index block. So solution, we can make another level of index. How can you search the data? For example, I'd like to search 41. 41 to access the 41. Where's the pen? I need to make the string. That from my first one of that. Anyway, so I'd like to search for example, query is to select as studies from employee where let's say this is a social security number. Is 41. Okay? This is our query. So first option, query optimizer will consider this one as a binary search. Okay? So number of block divided by 2. That is one option. Another option is you will have the 2-level index, okay, for the primary key. So we can use the binary search from the first level, okay, cut in half. So 41 is less than 55. Okay, so going to cut in half, then 35, right? So going to this one. And 41 is bigger than 39, less than 44. So going to 35, and finally this. How many IO do you need when you search the 41 record? How many IO in this example? 5. 5? How many? Who said 5? Okay. No extra point. Good try. 3? Yes or no? That determines your extra point. Yes? Yes, correct. So 3. Why? This is 1. Even though you apply the binary search here, how many IO do you need? It will be performed in the memory. So we don't consider divide to half. As long as it's 1 block, it's 1 IO. We consider physical IO, not memory. Okay? So once we read the data, we can reuse in the memory. So 1, 2, and finally 3 for data. So 3 IO is enough to access the data. So that is how it works. This one is still used for sequential, the 5. So which is called index the sequential access method ASM5. ASM5 is used for IBM machine, especially for the It's a mainframe. It's called a mainframe. It's not the. They use the different operating system C. 80 C series. Anyway, it's a C series. They change it every time the model number or the classification, but it's a C80. The operating system is based on the such a ISAM file. So file itself is ordered, but index also that include. So we don't have to use a DBMS, separate DBMS. It works. Still used in financial sector because it's reliable and very fast. Okay, but not much flexible, unlike the relational database.
Professor.
Yes.
In this slide, instead is second level.
Second level is this.
This one is first level.
Yeah, first level, second level.
So in slides.
It's a first. Yeah, it's a first level, second level. So I mistake. It's not very important. I'm not going to answer. Okay. If I'm confusing, then we'll appeal your question. Okay. So this is a first level and second level. You can make the third level if that is big. Okay. So you can verify how much fast it is when you are using the index. Okay. In this case, for example, there's the 4 block or something like that. Why don't you start by yourself? Okay. From the same example of the second. Okay. So we have the 3 level, 4th level, 5th level. Eventually, that indexing structure will be like this one, which is called multi-level tree structure. Okay, you can see it. The example over here. Where is it? There was the. I don't understand. Am I wrong? There should be the table, but anyway, I don't know. Somebody did it. So let's take a look at this one. So if we make the higher and higher and higher level, it will be eventually tree structure. What is a tree? Tree is that?
It's a data structure.
It's a data structure. It has node. What? How many different types of node? Root node, internal node, and leaf node. And also there exists a relationship. What? Between the nodes. What kind of a relationship? Parent and children relationship. How many parents? One parent. How many children? Many children. That is this relationship. Then root node does not have any parent, while leaf node does not have any child node, and internal node they have both of them. This is the tree structure. Actually, if I need a second job, or if I'm fired right now, I'd like to be a tree service guy. Do you know why? Do you know how much it costs to cut down the one tree? This big? So easily 1,000. Really very expensive. So, and also if you prune the branches, even though you prune the branches around your backyard, it easily costs 2,000, 3,000, something like, depending on the height of your tree. So I got the estimation to prune out the one cup of tree and cut down the one tree. So they actually gave me the offer 2,000. One is 3,300, another one is 2,500. So I'd like to be a tree guy. So very expensive. But tree structure in computer science is a very good data structure. For what? When do you use a tree structure? Organize such a data. Yes, that's the correct answer. It's where you can see the relationship. Also, because if you have something classifier like the less than 5 goes to the left hand side and bigger than, equal or bigger than 5, equal or bigger than 5 is the right hand side. Okay? Then you can search, and if not, you can find the data. So we can use easily this one to search the data using such a search tree. It's very easy, very simple. You can easily implement. It's kind of the several minutes, the classroom, the project. Okay? You want to do that right now? So this is the search tree. So we can use such a search tree. At this time, each node is what? Block, index block. Okay? Each node represents. So which means inside the node we have what? Key entry. Keyword plus pointer. Keyword plus pointer. Each node has such a thing. So in other words, we can actually redraw the tree structure like this one. Block, 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 and each block has the 111 has the pointer to where? This is the data file, the data file pointer.